So, good day everyone. Good day, Mamel. Today we are going to discuss about the lesson 4. By the way, we are the group 4 and our topic is all about climate. So, the first topic about climate is atmosphere. So, what is atmosphere? So, the atmosphere is layered with more massive molecules near the ground surface. Circulation in the troposphere redistributes heat and moisture. The composition of the atmosphere influences how much heat energy is stored, and climate refers to the atmosphere, how it behaves, and how it is composed. So climate processes involve the movement of storage of energy, including the interactions with the land surface and with oceans, since kabaluman jud ta nga ang oceans is main benefactor within the climate nga pwede siya cause of certain nga climates. So rising sea levels that threaten coastal Florida are one examples of this interaction. So at the atmosphere. The Earth's atmosphere consists of gas molecules, relatively densely packed near the surface, and thinning gradually about 500 kilometers or about 300 miles above the Earth's surface. So if magsugod ta sa surface pataas, pag-abot nato or paglapaw nato within 500 km, ang gas molecules magkauubos or magka-thin na siya. That's why astronauts, kung mugawa sila sa outer space, need sila og ilang kaugalingong suit para makabreathe og oxygen. In the lowest layer of the atmosphere, air moves ceaselessly, flowing, swirling, and continually redistributing heat and moisture from one part of the globe to another. So that's why natay laylay itong mga temperatura like init days ato sa ubang lugar kay bugnaw. The daily temperatures such as wind and precipitation that we call weather occur in the troposphere. So ang troposphere diri may tabo tanang mga climates, diri nato makuan atong wind and precipitation. Long-term temperatures and precipitation trends we refer to as climate. So climate muna siyang pasabot. Example sa climate is atong nagian karon nga El Nino or drought or grabe nga kainit. Since long term siya. Pero if dali ra siyang mahuman, di siya matawag nga climate. And next is, the earliest atmosphere on Earth probably consisted of mainly of hydrogen and helium. So, ang pinakaunang atmosphere on Earth is consist of hydrogen and helium. Over billions of years, most of that hydrogen and helium diffused into space. Volcanic emissions or ang paggawa sa mga or ang pag-emit og mga sa volcan or ang pagbuto sa mga volcano added carbon, nitrogen, oxygen, and sulfur, and other elements to the atmosphere. Virtually all of the molecular oxygen we breathe was probably produced by photosynthesis in blue-green bacteria, algae, and green plants. So, ang first nga virtually molecular oxygen was produced by the first bacteria, which is algae or green plants. Now, clean, dry air is 78% nitrogen, and almost 21% oxygen, with the remaining 1% composed of argon, carbon dioxide or the CO2, and a variety of other gases. Now, water vapor, H2O in gas form, varies from 0 to 4%, depending on air temperature and available moisture. Minute particles and liquid droplets, collectively called aerosols, also are suspended in the air. Atmospheric aerosols and water vapor play important roles in the Earth's energy budget and rain production. Kaning aerosols o ang water vapor mas turn siya sa clouds, which in time to time produce mass rain. So next, we are going to discuss about the troposphere. Now, the troposphere is the lowest layer of Earth's atmosphere. Naa siya sa maba or namo ni siya ang layer sa Earth nga naata nagapuyo or within most of the mass, about 75 to 80% of the atmosphere is in the troposphere. Naadali nga itong enough ng oxygen para makabreathe ta. And most types of clouds are found in the troposphere. And almost all weather occurs within this layer. Dili na itabo tanan nga weather like rain, kainit, snow. Within the troposphere, air circulates in great vertical and horizontal convection currents. So, na siya kagulingong currents ang air within the troposphere. Now, constantly redistributing heat and moisture around the globe. Muna siya ang gingon ganiya nga para ka na nato nga makagtagamtam tag-init, walang other mga places bugnaw kay distribute man siya og heat from places to places. The troposphere ranges in depth from about 18 kilometers or 11 miles over the equator to about 8 kilometers to 5 miles over the poles where air is cold and dense. So, ipasa na ako na siya sa line reporter. Thank you.
Ozone layer and stratosphere. Ozone layer is also known as ozone shield is a region of Earth's stratosphere that absorbs most of the sun ultraviolet radiation. Absorption of UV radiation by ozone also protects living organisms on Earth because UV radiation damages living tissues. Stratospheric air cannot continue to rise when it is cooler than the surrounding air, so there is a little mix across this boundary. The stratosphere extends about 50 kilometers to 31 out from the tropopause is far more dilute than the stratosphere, but it has similar composition except that it has almost no water vapor and nearly 1,000 times more ozone. The stratosphere is stable because the air temperature increases with high up to stratopause, which is the height of the temperature inversion. The increased temperature in this layer is due mainly to UV absorption by various chemical space, including ozone and molecular oxygen present in the stratosphere. Maximum heating takes place in the upper part of the stratosphere because of the stable air pollutant mix is suppressed within this layer. Those natural and synthetic chemicals that reach the stratosphere from the troposphere tend to diffuse upward very slowly within the stratosphere.
So, the mesosphere. The mesosphere lies between the thermosphere and the stratosphere. Meso means middle, and this is the highest layer of the atmosphere in which all gases are all mixed up rather than being layered by their mass. The mesosphere is 22 miles or 35 kilometers thick. The air is still thin, so you won't be able to breathe up in the mesosphere. But there is more gas in this layer than there is out in the thermosphere. So, have you seen a meteor shower? Where meteors burn up and streak across the sky? Some people call them shooting stars. Those meteors are burning up in the mesosphere. The meteors make it through the exosphere and thermosphere without much trouble because those layers don't have much air. But when they hit the mesosphere, there are enough gases to cause friction and create heat. This leads to the mesosphere to have a high concentration of iron and other metallic atoms, as the material from the meteor will vaporize in the mesosphere. Moving on to the thermosphere. The thermosphere lies between the exosphere and the mesosphere. Thermo means heat, and the temperature in this layer can reach up to 4,500 degrees Fahrenheit. If you were to hang out in the thermosphere though, you would be very cold, because there aren't enough gas molecules to transfer the heat to you. This also means that there aren't enough molecules for sound waves to travel through. This layer of Earth's atmosphere is about 319 miles or 513 kilometers thick. which is thicker than the inner layers of the atmosphere, but not nearly as thick as the exosphere. The thermosphere is home to the International Space Station as it orbits Earth. This is also where you'll find low Earth orbit satellites. I would also like to add that the thermosphere has a high amount of X-ray and UV radiation, since it absorbs the sun's rays. There is a lot going on in the thermosphere.
Evaporated water. Much of the incoming solar energy is used up in evaporating water. Every gram of evaporating water absorbs 580 calories every energy as it transforms from liquid to gases. Water vapors in the air stores that 580 calories per gram and overall stored heat latent heat. Later, when the water vapor condenses, it releases 580 calories per gram. Globally, latent heat contains huge amounts of energy, enough to power thunderstorms, hurricanes, and tornadoes. Rain falls when there are two conditions. The first condition is a moisture source such as an ocean from which water can evaporate into the atmosphere. And the second condition is the lifting mechanism. Lifting is very much important because air cools at high elevations. Lifting happens when the winds push warm moisture up and over mountains. This also happens when weather systems collide. It also happens when hot air warmed near the Earth's surface on a sunny day rises in convection currents. Any of these three mechanisms can cause air to rise and cool. Moisture in the cooling air then condenses, and we call this moisture falling as the rain falls low. So when we say evaporation, this refers to the process that changes liquid water to gaseous water, which is what we commonly call the water vapor. Water moves from the Earth's surface to the atmosphere via or through evaporation. And evaporation occurs when energy or the heat from the sun forces the bonds that hold water molecules together to break. The next is ocean currents. Warm and cold ocean currents strongly influence the climate conditions on land. Surface ocean currents result from wind pushing on the ocean surface. As the surface water moves, deep water wells to replace it, creating deeper ocean currents. The differences in water density, it depends on the temperatures and the saltiness of the water, also drive ocean circulation. Huge cycling currents called gyres carry water from north and south, redistributing heat from low latitudes to high latitude. Just for example, the current from Alaska flowing from Alaska southward to California. This keeps San Francisco cool and foggy during the summer. Thermohaline circulation refers to a surface and deep water circulation system where both temperature and salt concentrations control the density of water and contrast in density drive its movement. So ocean currents only refers to the water driven by the wind density of differences and tides. Ocean currents describe the movement of water from one location.
Everyone, especially to you, Mamel. I am James Marvin Benillas, and I am 14 climate change over time and ice cores. So, Milankovitch cycles drive long-term climate changes. So it means that these cycles drive long-term climate changes. Ice cores contains CO2 and oxygen isotope used to construct past temperatures and atmospheric composition. So ice have contains ice cores contains CO2 and oxygen isotopes and use it to reconstruct past temperatures.
So El Nino is one of the example of an ocean atmospheric because of its heat. Climatologist Balance Broker has said that climate is an angry beast and we are poking it with sticks. He meant that we assume our climate is stable, but our truthless actions may be steering into sudden and dramatic changes. So, criminologist Balance Broker said that climate is an angry beast that we can poke with sticks. And he meant that we assume our climate is stable, but truthless action may be steering in such a dramatic changes. How stable is climate? So, Balance Broker said that it depends upon the time frame you consider. Over centuries and millennia, we know that climate shifts somewhat, but usually we expect little change in the scale of human lifetime. So, over the century and millennia, kabalo na tanad, climate shifts somewhat usahay init, usahay ulan, but usually we expect little change on the scale of human lifetime. But this is might it change. This is no longer a reasonable expectation. He said also that this is not no longer a reasonable expectation. If climate does shape how fast environment, how might it be changed, and what will those changes mean for the environmental system of which we depend? So, if ang climate may shape, how fast might it change, and what will those changes mean for the environmental system on which we depend? So, magdepend na sa climate change. Ice cores. Climatologists have discovered that by drilling deep into an ice sheet, they can extract ice cores from which they can collect air bubble samples. So climatologists nakadiscovered sila by drilling deep into an ice sheet that they can extract ice cores that they can collect and they can collect air bubble samples. Samples taken every few centimeters show how the atmospheric has changed over time. So, magwag samples taken every few centimeters show how the atmospheric has changed over time. So, ipinaagi sa samples, makabalo sila kung sa atmospheric has changed over time. Ice core records have revolutionized our understanding of climate change. So, ice core revolutionize ang atong understanding of climate history. We can now see how concentrations of atmospheric CO2 have varied. We can detect ash layers and spikes in sulfate concentration and record volcanic eruptions. So, we can now see how concentration of atmospheric CO2 have varied. Makadetect na tayo like ash layers and spikes in sulfate concentration that cause volcanic eruptions. So as you can see that in the picture, they have a lot of ice. That is the example of ice cores. And thank you.
So, natural climatic swings. More dramatic changes are associated with periodic shift in the Earth's orbit and tilt. These are known as the Milankovitch cycle, after the Serbian scientist Milutin Milankovitch, who first described them in the 1920s. There are three of the cycles. One is the Earth's elliptical orbit stretches and shorten in cycle of about 100 years. Number two is the Earth's axis changes in angle of tilt in 40-year cycle. Third is over a 26 years period, the axis swivels like out of the balance spinning top. These cycles cause variation in the intensity of incoming solar energy at different uh, latitudes and in intensity of summer heating or winter cooling. So, in simpler terms, Milankovitch cycles are periodic changes in the orbital characteristics of a planet that control how much sunlight it receives, thus affecting its climate and habitatly over hundreds of thousands of years. So the interplay of the cycles also seems to explain the glacial periods of the last 800 years, which you can see in the cold warm cycle. For example, if the Webull orients the North Pole toward the sun in summer, then there is substantial summer warming and overwarming of the Earth. With a wobble point towards the North Pole away from the sun, the northern summers are cold and there is global cooling. Similarly, the axis tilts toward the sun, the poles warm, and when the axis is more parallel with the sun, the poles warm less. So, volcanic eruption can cause sudden climate shift, but usually only for a few years. One exception was the explosion of Mount Tuba in western Sumatra about 73 years ago. This was the largest volcanic catalysm in the past 28 million years. The eruption ejected at least 2,800 kilometers of material. Compare this to the 1 kilometer emitted by Mount St. Helens in Washington state in 1980s. Sulfuric acid and a particulate material ejected into the atmosphere from Mount Tuba are estimated to have dimmed incoming sunlight by 75% and to have cooled the whole planet by as much as 16 Celsius for more than 160 years. In climate history, the 160 years in a short time, however, and this was the largest eruption in 28 million years. So volcanoes are a notable but not dominant factor in recent climate trends. So a natural climatic swing is a fluctuation or a variation of climatic tendencies over prolonged periods of time, usually decades to centuries. They may be due to natural causes like solar radiations, volcanic activity, ocean currents, and changes in Earth's orbit affecting temperatures, precipitation, and other climatic parameters.
Good day, my name is Ijuri Cabanek, and now let's move on to the next topic, which is the El Nino or Southern Oscillation. So, on the scale of years or decades, the climate also changes according to oscillations in the ocean and atmosphere. These coupled ocean-atmosphere oscillations occur in all the world's oceans, but the El Niño or Southern Oscillation, or known as ENSO, is probably the best known. ENSO affects weather across the Pacific and adjacent continents, causing heavy monsoons or serious droughts. So we usually experience El Nino during summers, and we also know this locally as tagtuyot, which is evident ni siya sa example if ang soil nimo is malana kaayo tas manliki ang soil, evident na siya na iko na nag El Nino ang typically that place. So fishermen in Peru were the first to notice irregular cycles of rising ocean temperatures because of the fish disappeared when the water is warm. They named this event El Nino, or the Spanish for the Christ child, because it often occurs around Christmas time. The counterpart to El Nino when the eastern tropical Pacific cools has come to be called La Nina, or little girl. And now let's move on to the next topic, which is the evidences of climate change. The Killing Curve documents changing in CO2 concentrations, na clear evidence for human role in current o climate change. So ang mga polar regions o mga continental are niinit, mostly niinit siya rapidly. Many scientists consider anthropogenic human-caused global climate change to be the most important environmental issue of our time. So John Tyndall measured the infrared absorption of various gases and described the greenhouse effect. So in 1895, Svante Arrhenius, that received a Nobel Prize for his work in chemistry, predicted that CO2 released by coal burning kanang magsunog og mga uling. Muna siya example na mo-release og CO2 na maka-contribute siya sa global warming. And also pivotal evidence that human activities are increasing sa atong atmosphere or na CO2, which came from an observatory on top of the Mauna Loa volcano in Hawaii. So the observatory was established in 1957 as part of an international geophysical year to provide atmospheric data in a remote or pristine environment. So measurements taken by atmospheric chemist who's known as Charles David Killing showed CO2 levels increasing about 0.5% per year.
Hello everyone, I am Princess Kyoja F. Dison and this is my report in GE10. The topic is rising heat waves, sea levels, and storms. The IPCC's assessment report presents a variety of climate scenarios for predicted emission of greenhouse gases. For each scenario, the IPCC modeled future emissions starting in 2000. Scenarios differ in expected population growth, economic growth, energy conservation and efficiency, and adoption of greenhouse gas controls or lack thereof. The different scenarios project a temperature increase by 2100 of 1 to 6 degrees compared to temperatures at the end of the 20th century. Observations since the fourth assessment report in 2007 shows that all the IPCC scenarios were too conservative. Greenhouse gas emissions, temperatures, sea level, and energy use have accelerated faster than even the worst IPCC projections. Sea level rise, estimated in 2007 to be 17 to 57 centimeters by 2100, is now expected to reach 1 to 2 meters by 2100. Policy have made little progress in finding solutions. Climate control is a classic freerider problem in which nobody wants to take action for fear that someone else might benefit from their sacrifices. So, what I've learned is the IPCC's assessment reports outlines different scenarios for future climate based on factors like population growth, economic trends, and efforts to control greenhouse gas emissions. These scenarios project a range of temperature increase by 2100 from 1 to 6 degrees Celsius compared to the end of the 20th century. This means we could experience more frequent and intense heat waves, rising sea levels, and stronger storms. To address these challenges, it's crucial to take action now by reducing greenhouse gas emissions, conserving energy, and transitioning to cleaner sources of energy. By doing so, we can work towards a more sustainable and resilient future for our planet.
Greenhouse gases are gases in the Earth's atmosphere that trap heat and contribute to the greenhouse effect. These gases include carbon dioxide, methane, nitrous oxide, and fluorinate gases. While greenhouse gases are naturally occurring human activities such as burning fossil fuels, deforestation, and industrial process have a significant increase their levels in the atmosphere. So this burning fossil fuels and deforestation causing climate change. This is the producing gases that can affect our atmosphere. The greenhouse effect is essential for maintaining Earth's temperature and making it habitable for living organisms. However, the excessive emission of greenhouse gases have led to an enhanced greenhouse effect, causing global temperature to rise. This phenomenon known as global warming has far-reaching impacts on the planet's climate, biodiversity, and ecosystems. Carbon dioxide is the most abundant greenhouse gas emitted by human activities, primarily from burning fossil fuels for transportation, electricity, generation, and industrial process. Methane, another greenhouse gas released from agricultural practice, landfills, and production and transport natural gas and oil, not nitrous oxide comes mainly from agricultural activities such as fertilizer use, while fluorinate gases are used in refrigeration or conditioning and the production of electrical equipment. The excessive accumulation of greenhouse gases in the atmosphere is causing changes in Earth's climate, leading more frequent intense heat waves, wildfires, and hurricanes, and extreme weather events. Rising global temperature are also melting polar ice caps, causing sea levels to rise, the threatening coastal communities such as flooding. Additionally, change in climate pattern impact agriculture, biodiversity, posing serious challenges to food security and ecosystem worldwide. Addressing the issue of greenhouse gas emission requires global cooperation and collective action to reduce reliance on fossil fuels, increase energy efficiency, transiting to renewable energy sources, promote sustainable land use practices by mitigating greenhouse gas emission and adapting climate resilience strategies which can help slow down of global warming and the planet for future generation. There are several strategies and initiatives that can help reduce greenhouse gas emission and mitigate the impact of climate change. One effective investing in renewable energy such as solar and wind and hydropower. So this is the mga activities na makahelp para reduce greenhouse gases like solar or wind or hydropower. Pwede na siya natong use para dili kayo magasto ka ng electricity energy. So which produce electricity without emitting greenhouse gases by transitioning to clean and sustainable energy sources. Countries can reduce their carbon footprint and limit the amount of greenhouse gases released into the atmosphere. Reducing deforestation and promoting forest conservation are also important ways to mitigate greenhouse gas emission. Forest plays a crucial role in sequestering carbon dioxide from the atmosphere and helping regulate the Earth climate. Protecting and restoring forests can preserve biodiversity and maintaining ecosystem services and reduce the amount of carbon dioxide released into the atmosphere. So kuan pod magplanting ana para pud makatabang sa ma-reduce greenhouse gases kay usap po ni ang mga forest mga plants makatabang para ma-reduce ang mga greenhouse gases. So
I am Princess Closure of the Sun, and my topic is ice loss. Climatologists warn that summer sea ice in the Arctic Ocean has thinned and declined in extent by about half. Late summer Arctic ice may be gone entirely by 2030 or sooner. Melting ice has a strong positive feedback effect. As ice melts, exposed water absorbs energy and warms. Warm water retains its heat long into the fall, reducing the new ice that forms over winter. Thinner, less extensive ice melts rapidly in spring, allowing greater warming the following summer, further enhancing heat absorption. A warming, ice-free Arctic Ocean contributes to warming worldwide. In addition to providing a vast new thermal mass of warm water, a warm Arctic accelerates warming of land masses in Siberia and Canada. Melting permafrost in Canada and Siberia releases CH4 and CO2, creating another positive feedback. An ice-free Arctic also influences ocean circulation, allowing fresh low-density water to interrupt thermohaline circulation. A warmer Arctic also alters the ecosystem. Polar bears, walrus seals, and most other Arctic mammals are adapted to live and hunt from the ice. Algae and plankton that grow under the ice are often the foundation of an ecosystem. Cold water fish are replaced by warmer water fish, and birds may not be able to find suitable fish in suitable locations for feeding. The decline of Arctic sea ice is accelerating global warming. As ice melts, it exposes water, which absorbs more heat, further melting the ice. This feedback loop contributes to a warmer Arctic, releasing methane and CO2 from melting permafrost. An ice-free Arctic disrupts ocean circulation and affects ecosystems, endangering species like polar bears and altering marine life. Urgent action is needed to address this crisis and mitigate its impact on our planet.